So thank you for being here. We start with this session, Building Energy Performance Optimization and Predictions. We have the first presenter, Mr. Aleksandar Končar, who is presenting a work titled BMS Controls Potential for Enhanced Use of Economy Cycle in Temperate Climate Conditions, Improvement, Energy Efficiency of HVAC Systems and Indoor Environmental Quality. Please, the floor is yours.
Thank you. Good afternoon, ladies and gentlemen. It is a great pleasure to be here and to be given the opportunity to present in this conference. I would like to thank all the people involved in organizing this great event, particularly my dear friends, professors Marija and Branislav Todorovic, on their tireless efforts to make this conference happen. The fact that this is the 47th conference, the biggest regional HVAC conference, and the fact is that it grows in every aspect every year, is the best indication of its success now and hopefully for years to come. My presentation is about a discussion on how to improve traditional economy cycle, energy management feature to improve energy efficiency of heating, ventilation and air conditioning systems by using outside air for cooling when outside air conditions are suitable. So that is well recognized traditional way of using outside air for cooling. So this paper proposes a method to increase operating hours of economy cycle and to improve energy efficiency of HVAC systems by using less typically chilled water for cooling applications. So what is economy cycle? So I suppose that most of you are familiar with that energy management features in which we basically use outside air for traditionally for cooling. So we replace mechanical cooling, AC compressors or chilled water, or minimize their use for cooling when outside air conditions are suitable. When outside air is, we can say, cool enough to be used for cooling. So that is something that traditionally has been used for many years. This paper proposes that economy cycle can be also used for heating and also in dead band temperature region, which would basically further improve energy efficiency of heating, ventilation and air conditioning systems and minimize the use of mechanical cooling, chillers or DX equipment. Significant benefits of proposed method is improved indoor air quality, because when economy cycle is used, basically we use mostly 100% fresh air as opposed to standard recirculation of air-conditioned air in standard applications. Reduction in energy consumption consequently reduce energy cost and greenhouse gas emissions. How does it operate? So in very simple terms, basically we are talking about air handling units. So return air is discharged, blocked. We have motorized damper shown in the middle that is basically closed, and return air is expelled, and we use 100% fresh air for cooling to provide full cooling or to supplement cooling provided by minimized amount of chilled water. So that is known feature for many years, implemented at air handling units in the form of motorized outside air, return air and spill air dampers, fitted with actuators, controlled by suitable software through BMS, Building Management System, that simply sense conditions of outside air in line with a given control criteria via building management system and engages and disengages economy cycle on as needed basis. this is another schematic, so it's maybe clear that fan is expelling supply air into the room and also sucking return air, of which one portion is expelled as exhaust air, and the remaining portion, let's call it 80% of return air, is mixed with the 20% of fresh air, filtered, going through cooling heating coil, and so on. So main point of this discussion and what papers is presenting is the idea to use economy cycle beyond standard controls, traditional controls, just for cooling. So if we look at graph, blue line on the graph shows opening and closing modulation of chilled water valve, starting opening in the middle of cooling region. The green line is showing a modulation of outside air damper. This is the one that basically control engagement and disengagement of economy cycle. So traditionally, this green line would be pushed to the right, starting from the beginning of a cooling region. You can see that number 23. Now, we are proposing to push it to the left. So we have modulation of outside air in that band region, meaning that economy cycle can be activated for pre-cooling, which means we are prolonging hours of economy cycle, increasing energy efficiency of HVAC system and reducing needs for chilled water. To make sure that we are not triggering heating, the damper is fully closing when we approach near heating region, shown on the graph at 21.3 degrees. In this case, we put set point at 22 with dead bands plus minus 1 degree. So this is simple modification, but very powerful, considering that economy cycle used in its traditional terms just as a first stage of cooling, when there is call for cooling, by minor changes of programs, of controls, using the same infrastructure, all of a sudden, basically, we are achieving savings up to 30% higher than what economy cycle achieves anyhow. And in addition to that, we improve indoor air quality. To be able to maximize operating hours of economy cycle, there are a couple of other features that, other control features that we can apply. Typically, BMS companies would disengage or disable economy cycle if relative humidity of outside air is above 60, typically 60 or 65%. And they state that basically they do that because there is too much moisture in the air. Now we know that relative humidity is called relative humidity because it doesn't tell us how much moisture is in the air. So in my presentations, I very often point at one simple example. If you have 70% relative humidity and 17 degrees outside air, that air has moisture equal to temperature 22 degrees and 50% RH, which means that air can be used for economy cycle. So suggestion is to modify control limits at BMS from relative humidity of absolute air to outside air to absolute humidity of outside air. That again increase operating hours of economy cycle. The other one is we should avoid small dead bands for spaces that can have more tolerable limits, such as shopping centers or any kind of space with variable occupancy, foyers, museums, food courts. So if you put wider dead band, then we again increase engagement of economy cycle. And the same applies for relative humidity criteria. While we understand that for close control environments such as museums or data centers, relative humidity criteria are kind of narrow, that can be widened for applications such as shopping centers or office buildings. So with the three or four small modifications of control strategies, control parameters and control limits, we can increase use of economy cycle by up to 30%, which can translate to good energy cost savings and greenhouse gas emissions reductions, achieved in a very cost-effective way because infrastructure remains the same. All we have to do is just to pay for a small modification of software. And that widely apply for any kind of commercial air conditioning system employed in hotels, hospitals, shopping centers, office buildings, clubs, museums. So this graph is showing modulation of outside air damper in cooling and pre-cooling mode. So traditionally, that green line would be moved to the left, parallel to the blue line, starting from 23 degrees point. Now you can see that we pushed it to the left, and by doing that simply we enabled pre-cooling and longer operating hours of economy cycle. And as I said, to make sure that we can't trigger heating, dampers closes when we approach to heating region, in this case by 0.3 degrees. Next graph is showing operation of modulation of economy cycle damper in heating mode, which means in simple terms, if total energy of outside air is less than total energy of return air or enthalpy, why not to use that air to reduce amount of hot water required for space heating. This strategy has been implemented at quite a few of my clients in Sydney, hospitals, office buildings, even museums. Works quite well. Some people said you can't achieve much with heating, particularly in temperate conditions such as Sydney, but we proved that in many cases when we have mild weather conditions, early morning, if you have simply more energy in outside air, sunny morning, why not to use it to reduce the amount of hot water required for space heating? So that works quite well. Just to mention something about traditional controls of economy cycle observed at many commercial clients. Doesn't matter whether we are talking about hospital or hotels or shopping center, museum, club, where for some reason could be old design school, control school, I'm not sure. So point A, where economy cycle set point is put at 16 degrees. So simply, if outside air is cooler than 16 degrees, let's use it. Obviously, the strategy works, but it disadvantages energy efficiency features because simply, in many cases, you can provide cooling with air warmer than 16 degrees. Particularly if you put a cooling set point at reasonable 23 degrees, 22 set point plus minus 1 that band, which means that we can maximize use of economy cycle well beyond if outside air is just colder than 16 degrees. A second strategy is even worse. In some cases, control people set outside air temperature to be close to supply air temperature, which is typically 12 to 13 degrees for chilled water air handling units, or down to 9-10 if you're talking about DX systems. And that one again severely disadvantages use of economy cycle because they disable economy cycle if temperature is arguably higher than 14 degrees, which simply doesn't provide opportunity to economy cycle to run much longer hours and to save energy, to reduce greenhouse gas emissions and to reduce energy costs. Point C is the one that I already mentioned, that for unknown reason, BMS control people put a control limit on outside air, stating if relative humidity is above 60%, disengage economy cycle, which is that open different discussion on why control people play with the design features, because only designers should really prescribe how systems should be controlled. But unfortunately, in many buildings, at least in Australia, very complex buildings with a complex air conditioning equipment, chillers, primary, secondary chill water pumps, cooling towers, VSDs on pumps and fans, are left in the hands of 2 or 3 facility managers or HVAC technicians who simply don't understand air conditioning design. So that opens another topic that people who are not involved and don't understand HVAC design shouldn't be playing with controls. Control strategy at point D is the one that is the most efficient based on enthalpy differential. So we're looking at total amount of air in return air and outside air, together with a certain control limits and control strategies. So this is the one that is recommended. So opportunities to optimize economy cycle is don't use it only for cooling, but use it for pre-cooling and heating, and give it opportunity to run much longer hours by widening temperature limits, by widening RH limits, by introducing limits in terms of absolute humidity of outside air, and employ enthalpy differential control strategies. So all this is relatively simple, but surprisingly not employed at, I would say, 9 in 10 buildings. 90% of buildings would still have all strategy that leave a lot of space for improvement. Do's and don'ts. Do's in terms of what good practice is, don'ts in terms of what we shouldn't do. So in terms of do's, that's kind of conclusion. Use enthalpy differential control strategies. Use economy cycle for pre-cooling, cooling and heating. Provide wider space temperature. Use it as part of optimum start BMS function. So with BMS, you can employ optimum start function. So you don't have to start air handling units at 6 o'clock if people come into the building at 8 o'clock. That can be justified if you're talking about peak of winter or peak of summer. But if you have mild weather conditions, you can start your system 15 minutes before people arrive. And optimum start feature of BMS calculate the latest start of. And during that latest start, if outside there is of suitable conditions, economy cycle can be employed. So that should be also added to control features that economy cycle can override optimum start conditions. Economy cycle can also cause inefficiencies if not maintained properly. If you have inaccurate sensor, it can open when you have 40 degrees outside air temperature at peak of summer. So it is important that maintenance is done properly, that field sensors, relative humidity, temperature sensors are calibrated properly, and also stroking of dampers should be regularly checked. So even if BMS is showing that damper is open or closed, maintenance people should check in the plant or whether dampers really reflect that position. Needs for restroking is very common, simply to make sure that damper is fully open or fully closed as per BMS controls. Checking control sequences is also recommended. Economy cycle don'ts. So don't use solely outside air based only strategy. Don't use relative humidity limits of outside air, rather absolute humidity limits. Don't use narrow dead bands, because in majority of cases they can be widened apart from data centers, apart from close control environments, museums. If you're talking about shopping center, if you're talking about office buildings, that band of plus minus 1 degree seems to be quite reasonable, and just even that small modification can push economy cycle to run 10 to 20% more because of that difference between temperatures that trigger its engagement. So, to conclude, yes, simply use economy cycle in a recommended way, because that simply increase operating hours of economy cycle and save a lot of money in a very, very cost-effective way. Any questions?